In this video we have an exponential equation, and the first thing we want to notice here is that we have bases that we can make the same. In other words, this one has a base of 9, this exponential here. This one has one of 27, but I can write the 9 as 3 squared, and I can write the 27 as 3 to the third. And over here we have a 1/3, but that can be written as 3 to the negative 1. That's convenient because that means that we don't have to go through and take the log of both sides, which is something you do occasionally when you have an exponential equation. So let's do this here. We have the 3 squared is the 9, and that's taken to the 2x power. That's multiplied by 27, and let's write that as 3 to the third. And that's taken to the x squared power. And that's going to equal to, instead of 1/3, we'll write that as 3 to the negative 1. And then use laws of exponents. We've got power to a power here. We can multiply the exponents. So it's 2 times 2x will give me a 4x here. And then for this one, it'll be 3. Then power to a power again, multiply the exponents. This will be a 3x squared. That's equal to 3 to the negative 1. I can put these two together using the, again, laws of exponents. Multiplying powers of the same base. You break down the base at the exponent, so I can write this as 3x squared. 3 to the power of 3x squared plus 4x. And then on the right side, I got 3 to the negative 1. So I got a base. The base now is the same. So whenever you have, as I've done in several videos, if you have a base b, say taken to the x power, and that's equal to, again, the same base taken to some other power, y. And the only way that we can have equality here is if the exponents are equal, x equal to y. And again, the requirement here is conditions are that b has to be positive and b cannot be 1. Otherwise it's not going to work, because 1 to any power will give you the 1. So 1 to the 20th, 1 to the 30th, that's the same number, but the exponents aren't equal. So condition again that base has to be positive, not equal to 1. Now if that's the case, then these two exponents have to be the same. So that I can equate this. I could take a slightly different approach to this, but this is a one that is more common. 3x squared plus 4x then. Got the same base on both sides, so the exponents have to be equal. So 3x squared plus 4x has to equal to negative 1. That of course generates a quadratic equation. So we can solve this by factoring. Got 3x squared plus 4x. Add 1 to both sides. Makes it a plus 1 here. 0 on the right side. Now we have a quadratic equation. One side is 0, so we can go to the most common method here. If it factors, and this one does. So this would be 3x here. X here. Plus 1 here. And a plus 1. Product of two factors is 0, means 1, or the other factor is 0, or they're both 0. So we simply take each factor and set it equal to 0. So 3x plus 1 could be 0, or x plus 1 could be 0. And then we just solve these for x. So bring the 1 over to this side for the first one here. That's negative 1 divided by 3. One solution could be negative 1/3. Add negative 1 here for the second equation. Add negative 1 to both sides. Gives me x equal to negative 1. So the two solutions for this one are x equal to negative 1/3 and negative 1. And you can always go back and plug into the original equation to make sure they are solutions. I'll let you do that. They do check. So you should be able to plug in the values where x is and get the same number on both sides. Thanks for watching. We'll see you next time.